Good morning. So I think this is where we left off. We want to display the image that we made in the last step as a map layer. So I'm going to go ahead and copy the snippet to the clipboard, go over to the script. I think that's the script that we're working on here, and I'm just going to paste this in and uh, and then hit save. And I'm not going to hit run yet because it's not quite set up to run. So what this thing does is it first imports two modules, the one that I wrote that will allow you to kind of look at the histogram of this data values, and then one that is the palettes that's going to allow us to use a predefined color gradient to display the data. And so then the way that I've set up the snippet is the first thing you do is you define your viz parameters. So we're going to call those output viz, and it's a dictionary. And I've got this one key that's kind of commented out. We're going to uncomment it so that it's alive. And then I want to get the name of the band that we just made. And so I think if I go to the output image and go to bands, we renamed it. Sorry, I can't seem to grab it. Oh, it's so touchy. Here. If I double click on that, I can say copy, and then I'm going to go over to here and just paste within quotes because it's a string. That's our band name. And so what I'm saying here is we just have you know, just to be clear, we just have a single band image. So it's not critical that we define the band because by default it would just kind of use the viz parameters to display the only band in the image. But I have it set up this way just if you in the future want to use this for an RGB composite, this should help you do that. So the idea is that we're going to say, please look at the data in this band, and the x-axis of the histogram should go from 0 to 150, and then we're going to use the palette eventually is going to be this, that we're a yellow to red palette that's from the community palette resource. So then I'm going to uncomment the histogram and start filling out the arguments. The tool takes 5 arguments, and so I'm just going to, put my cursor there in that kind of second column that you might see it outlined. And it must be an image, not an image collection. So what I'm going to do here is um, grab the thing output image that we want, and then the 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 tool's set up sometimes it can be a little cranky if the image isn't clipped. So just to double check to make sure that this tool will work for this image, I'm going to just say please clip it by the AOI extent. In this demonstration, this may not be necessary, but in the future, should the tool throw an error because and complaining about the your image that's an input, the a good way to kind of fix that is to say dot clip and clip by your extent rectangle. So we're just going to do that here, and then just remember that you're going to have to put a comma after each item, and it's going to get mad temporarily until we start adding the next comment or the next argument. So then it says select one band at a time. So what I want to do is call this right here. I want to say, please use the bands that we've defined in the output viz, or the single band that we've used in our output viz. So to do that, I'm going to say, call the output viz dictionary, and then grab the band's key and use the first item in the list, which is going to be indexed to 0, because remember the way that the code editor works is that the first index is in a list is going to be you start counting at 0 rather than counting at 1, and so that's fine. And then I'm going to put a comment here, and then I need to define the resolution of the image, or basically what I want to calculate the histogram at. So I'm going to say 30 because that's the resolution of Landsat, but I actually want to kind of make sure you're aware of something here. I'm going to Earth Engine data catalog and look at the Landsat, and I think we're using Landsat 8. And then the way that the tool that Sophia wrote works is I believe it works with the top of atmosphere collection. And so then if you go to the bands here, this is the So there's the visible part of the spectrum, there's the kind of the extra blue that's added. There's the near infrared and the shortwave infrared. There's a panchromatic band, which is a finer resolution, but it just means it's essentially a black and white image. And then you start getting into these clouds and then the thermal infrareds. So these are the bands B10 and B11 that are used in the algorithm that Sophia wrote. And so you'll see that they actually, the sensor collects them at 100 meters. But then Earth Engine, as part of this product, what Google does is they resample it. So they take information, data that was packaged in a 100 by 100 meter pixel, and they repackage it into pixels that are 30 by 30 meters so that they all kind of line up with the other uh, pixels, except for the panchromatic, right, that are in this image. Is that okay? So anyway, just wanted to take that little sideline to show you that we're going to say 30 here, but actually the data are originally collected at 100 meters and then resampled down. Um, uh, or actually, I don't know, resampled up. I get confused if up versus down when people are talking about this. But anyway, we're going to say 30 for here. So next we need to kind of define what the minimum value and maximum value of our x-axis of histogram are. And we want to basically say, well, let's just again draw on stuff that we've defined in our Viz dictionary. So let's say that we're going to use that min value. So the first, we're going to say use the min key in this dictionary and grab the first item in that list. And that's going to be our minimum value of the x-axis. And then put a comma, because we're going to basically do the same thing. I'm just going to copy it, paste that here, and just change this to max. And then I want this, yeah, and still at 0. So this now, if I get this other line, because you can see that these are the things that kind of bother me. And then histogram, we're going to print out that label, and then let's go ahead and print out this object that has what should be a graph. And if you have any exclamation points here, just it's often because you're missing a comma. Each argument has to be separated by a comma. I'm going to save this because I'm feeling pretty lucky today, and I'm going to hit run. And it's going to crank through this, and it's going to take a while. First, you'll notice that there's this pause before anything happens. And that's what happens when you start adding these modules, is there's some fetching required on the part of Google that kind of slows things down a couple of seconds. And then there's the histogram. So what you can see from this is that we're not actually taking advantage of our display range. It's going to be, right now we're kind of stretching our colors, this yellow to red ramp, over a wider range of display values than that we have populated with data. So let's stretch this so that it goes maybe from 75 to 120. And so the easy way to do this is to now just go to your Viz parameters and say, I actually want you to go from a min of 75 to a max of 125, hit run, and that should now update your histogram here so that you can check. Again, you have to wait for the modules to load, and then it should start running through. And then at the base here, you should get a chart, and you have to wait for it. In the meantime, I'm going to start working on this last bit, which is going to be there's the histogram. So not bad, like 75 gets that tail, and then 125, probably clip it at 120. So let's just go ahead and do that. And then what is nice about this approach is now we can just go ahead and add the map layer, and we're going to add the output image, this one, and we're going to use the output viz, and we're going to call this output image, and I'm going to just make it false, and then wink at it at the end, and run it. And so we should now get, as it thinks about it, we should get our image here, and I'm going to probably tell those things to stop showing automatically, but there's our stretched um, land surface temperature image for Baltimore. And you can begin to kind of see here that you have, the cooler areas are often going to be associated with green space or water. And then you're going to have the hot areas. And then anything that is a kind of a dark smudge is going to be really hot. And so you can see um, some of these rooftops, um, and the difference between that black rooftop and the whiter rooftop comes out a little bit. But it could also be that this thing could be reflecting more, so it's not so hot. But it also could be a uh, a difference in time. So just remember that the we are looking at the land surface temperature data that we are looking at came from the summer of 2020, like between 20 and 22, so the last 2 years. But if that building could have been built in 23, so just remember that the satellite right now that we're comparing it to is not the same time period necessarily as the data that we are looking at the land surface temperature. I could ask you to make a RGB composite of the Landsat, but I'm not going to for this lab. Is that fair? I just hopefully that's understandable, and I'm going to save and then keep moving.